Okay, so in this chapter, we're going to finish off this section of the DVD where we've been modeling elements of the go-kart using sub-Ds. We're going to finish off with a little bit of a tough nut. So I'm just going to hide the elements that we modeled in the last chapter. And what we're going to focus in on is this cog over here. So what I'm going to do is I'm going to basically put some smoothing on it just to make it a little bit more interesting looking. And then I'm going to put some teeth along the edge here just to make it into a full cog. So before we do that, let's actually put an edit poly modifier on here, and it's going to make some changes to the model here. So let's see. Firstly, I'm going to get this edge here, do a loop selection, and pull it over here. I need to make this cog quite a bit thicker, so there we go. We'll do the same thing here, loop, pull it over. Let's do this from the top view actually. We can see that it's even. There we are, that looks pretty good. And now if we put a sub-D modifier on here, let's put a turbo smooth on. You can see one of the problems immediately is it becomes too soft. We've basically lost the hard edge form, which I really want to keep because this is a cog obviously, so it's an engineered item. It would be lathed actually, and then I guess the teeth are welded on, or it could be cast I suppose. But basically it would be a relatively hard edged item. So let's go back down here to edit poly, go back into subobject mode, and what we basically need to do is we need to add some beveling into these edges here. This is already beveled, so we need to get this edge here, this one here, this one. Basically, let me just turn on no back facing, makes selection a little bit easier. Basically any edges which aren't beveled. There we are. I'm going to loop select those, so we've got all the edges going round. We'll turn on show end result, and then we'll just go and chamfer. We'll see what we get here. So you can see this is going to give us our hard edges back, as you can see here. Just cancel that, and we'll turn off end result because I want to see what I'm doing here. I want to make these nice and hard, so let's go chamfer, put up some values here, and then we'll just put some more edges in here. So we'll just apply that. Let's go like that, apply, and then we'll make a smaller value here. Yep, that looks pretty good. Okay, that, and have a look up here. Yeah, that looks okay. If we show end result, you can see now we've got some nice hard edges there. But even though I say they're hard, they still have bevels on them, chamfers, which means that they'll pick up the light a lot better. So that's the basic part of getting the sub-Ds to work okay on here. What we need to do now is the teeth. So for that, let me just put wireframe mode back on here, and let me just go back down to the base mesh. Turn off show end result, and what we want to do is we want to get one of these faces and detach it here. So let's just do that. Let's shift copy that, copy it to an element, and then go up here, detach, and now it's a different object. So now I can actually go out here, and we can just select this object here. I'm in a bit of trouble getting it selected there. There we go. So the first thing we're going to do is let's go into subobject mode, and I just want to make sure I can isolate this from all the teeth around it. So I'm just going to select here, connect, and let's just turn on edge here, slide this into position here, connect. Let's try and get it as even as we can. Okay, and now what I want to do now is just extrude this out somewhat. Let's just zoom out so we make sure we don't actually extrude it too much. It's obviously a bit too much. Just dial this up. Group normal is okay. So we're just going to roughly get this right. This looks okay. And what we need now is a former. So what I mean by that is a chain would actually fit over these cogs, and therefore we need to create a circular element which actually represents the hinge of each link in the chain. So the easiest way to do that is if we go into cylinder here, turn on auto grid, we can actually create it on the surface of this cube here. And the really cool thing about that is then it's actually aligned to this cube. So we can go cylinder, auto grid, make sure we're on the right face here, and then we'll just draw it to roughly the right kind of size. Doesn't really matter about these dimensions. And that's that. Then we can rotate it, make sure we're in local coordinates. So you can see now it's aligned to this face. Just make sure snap's turned on, rotate it by 90 degrees. Now we'll just move it up here, make sure again it's in local for move. And what we want to do is we want to basically get this to the right kind of radius so that it makes sense for here. So it looks like, based on the thickness of this, that with this kind of radius, you probably want the chain to be this kind of height from here, which means that this is actually probably too high at the moment. So let me just crank up the sides here a little bit more. And we can just go in here. And I'll turn on edge. Yeah, make sure that's on. Move that down till it's roughly in the middle of the cylinder, as you can see. That's going to be our kind of tooth height. And this would probably have a little bit more room around it. So let me just undo that slightly. Let's move it down here. Move this up here. And that'll be a pretty good former for us now. So let's now put in some edges here. We'll just connect these a few times. We need a few edges because we need to actually, do some quite large changes here. And I'm just going to select these with loops. And do a loop selection there. Now I'm going to just scale in the edges here. Convert to vertex selection. Make sure edges is turned on. Just scale in here. So it moves along the edges. We'll get it to about roughly that point there. Same thing again. Want this to be quite a sharp point. We'll select these edges here again. Loop. Convert to vertex selection, holding down control, clicking on here. And again, we've got edge constraint turned on, so we can just pull this in here. So it basically matches our former. Same thing again, loop selection, control, click to convert, and in. And you can see now that we basically have the kind of shape that we want there. So that's looking okay. Let's pop a turbo smooth modifier on here to see what we're going to get. And you can see it looks okay. It's a little bit odd looking because the edges here are quite soft, so we need to harden those up. But once this is actually repeated around the cog, it should actually look okay actually. The main problem, as I said at the moment, is the edges are a bit too hard here. So what I'm going to do is I'm going to just go down here and let's just get this face. Scale it to local. I'm going to scale this in here. We want this to be quite a sharp point, really. And also this here could do with being scaled in slightly. Just a loop and then scale inwards. There we are. Looking pretty cool. So now if I show the end result, as I said, we've got some soft edges going on here. So what I want to do is I just want to put in a chamfer along here, and that should give us a hard edge, but it'll cause some problems down here which we'll have to resolve later. And you'll see what I mean by that when I actually do so. So let's just isolate that somewhat. So I'm just going to create one more subdivision down here. I'm just going to do a ring selection, and then I'm going to connect. Make sure it's just one. I've got that selected. I'm just going to move. I've got edge constrained on, so I can move it, and it'll just move down with these edges, as you can see. It's pulling this down. So that kind of pulls this down, as you can see. And now I can select these edges. So let's just do that. Turn off show end result. I just want to see these. So I want this edge, this one. This actually, we need to just isolate the top as well, actually, I think. Let's just try it without doing so. And now we can do ring selection. We got all the way around. Show end result turned on. Let's try chamfering. Obviously, we got a massive result because of this value. So we just need to zero that. And then we can just try using slightly larger values. You can see it's crossing over here already. So we need to keep this value really low. So let's try 0.5. So that looks okay, actually. It's causing a little bit of pinching at the top here, but I don't think that's too disastrous. I think when you zoom out, you're not really going to see that. Now, it is causing an issue, which you can see down here. And this really is something that we're going to have to fix. So let's just okay that. I think it's looking pretty good. It's given us a nice hard edge sort of tooth at this point. You can see, as I said though, you got this kind of folding under going on here. So let's just turn off show end result. And because of the scale here, it's actually quite difficult to work at this sort of size. So let's get this vertex here, and we're going to weld that to there, I think. What we could actually do probably to actually stop this overhang happening is we just need to put in some subdivisions here. So let's just try that. Let's select these edges here, and then we're just going to put in 2 subdivisions. And let me just turn off show end result. Deselect this for a second. Make sure this is constrained, and then just move this up here. Yeah, it's pulling it in slightly, I think, and kind of fixing some of the issues. And let's just do the same for this one here. Pull this up here into position. And I think we need to do the same here, obviously. So just connect and move into position. These edges are just basically creating, you know, some more geometry to interpolate between, and this should hopefully stop this sort of overhang that we've got going on. So let's just show that, and we need to do the same thing here. So let's just select this geometry here, try connecting. Yeah, you can see it's anchors things here quite nicely. So just grab this, pull this up to here. But actually, let me just try going over the edge here. So let me just try connecting that again. Yeah, that's a lot better. And in fact, I think we probably need to do that up here as well. So let me just undo this a few times. So let's start with here, redo this. Okay, that. Oops. Need 2 edges there. Okay, that. And then just pull these into position. You can see now it really pulls the geometry there into shape. Kind of hard to see what's going on with all the geometry there, so I'll just turn that off for a second so you can see what we're doing more clearly. Move this into position here. Okay, so look at that. Yeah, you can see this much better there. You haven't got that kind of weird overhang. So we should be able to do the same thing by doing exactly the same kind of modeling here. Connect that, move into position. Right stuff. Loop, move into position. Same thing around here. Connect. Zoom out slightly. Connect that. Deselect, move into position. And then here, loop, move into position. Show end result. And you can see now that if I just turn off wireframe display, you've got a much better curvature here. You can see it actually holds the curve all the way down to the bottom of the surface. And we've got a pretty decent looking cog at this point. the curvature here isn't so good, so maybe this could be adjusted slightly, but we've basically got what we wanted. So let me just pull this down here slightly, and then we can just make some quick adjustments to this here. Editable poly, vertex. Let's see, let's just grab here, loop, control R. I'll just turn off this here, fill this in slightly. I think that's enough really. So there we are. There we basically have one of the teeth. Now, what we need to do now is just repeat this all the way around. And what I'm going to do is I'm just going to turn off Turbo Smooth. I'm actually going to delete it because we really don't want to have Turbo Smooth applied at one level as we do it next. Now, there's two ways that we can create the teeth on this cog. We can either instantiate this individual cog tooth that you see here and keep them as instances, which would probably be it's the most efficient way you could actually build this geometry. The other way you could do it is that you could copy all of these teeth and then attach them together again and turn them into one object. This would be maybe a little bit easier to handle, but it wouldn't be as efficient in terms of rendering, because a lot of rendering engines have the ability to handle instance geometry in a much more efficient manner. So what we'll do here is, first of all, we'll just create this geometry going round, and then we'll decide what we're going to do with it. So create it first as instance geometry, and we'll give it a name so we can recognize it more easily. So let's just select the cog tooth, and we'll call it cog tooth 01, and it shares the pivot point of the original lathe that it was built from. So we don't have to basically get the pivot point of this and align it to the lathe. Because it was detached from the lathe, it has the original pivot. So we can basically array around that point. So I've got the extras tool panel visible up here. I've added a couple of extra commands on here which allow me to change whether I'm using my modeling lights or my rendering lights. And those are just simple macros. If you want to find out about macros and Mac scripting, then please check out our Mac Script Fundamental DVDs, where you can find out how you can create little macros like this to, in this case, turn on some lights and turn off other lights. And this script basically does the opposite of that, just turns on and off the opposite lights. But in this case, I'm not going to use a custom command. What I actually need here is the array tool that you can see here. So what I need to do is I need to array this tooth around a circle, and we need to do, now if we go back and we look at the original lathe, you'll see it has 48 segments. So we have to use that many segments to get a nice match with this. So let me just get out the calculator here. So here's the old Windows calculator, and we'll just do a very simple piece of maths. We'll just go 360 degrees divided by 48 cogs equals 7.5 degrees per cog. So we can now select the cog tooth, and we can run the array tool, as you can see here. They improved it greatly in a recent release of 3ds Max. I think it was version 7 actually, and they added the ability to preview what you're doing as either as a box or actually as geometry. We'll turn that on, and that will actually show us our teeth. You need to find the axis that you need to rotate around. So you can see here you can actually array by moving. So you can create arrays by moving, as you can see, or you can do it by rotating. You can see, or you can scale. You can create scaled arrays. Now in this case, we need to do a rotation, and we know it's 7.5, and I know from previous experimentation that it's on the y-axis. So if we crank this up here, and actually it doesn't seem to be working correctly. So let me just cancel that for a second, and let's just go to view. There we go, and we'll run the tool again. So let's just try that again. Turn on preview. There we go. It was because we actually had local coordinates turned on, so it was actually creating an array around its own axis, which wasn't quite correct. We needed to change it to view to actually be on the y-axis. So that's it with 4 degrees. 6, we know we need 7.5, so we're going to have to do a type in. And we need more than 11 teeth. We need 48, in fact. We just increase the count until we have, oh yeah, 48 teeth. As you can see, it matches it perfectly. So it goes around 360 degrees, 7.5 degrees per cog. 48 cogs gives you the full 360 degrees. And type of object, we can either do copies, instances, or references. In this case, we're going to go for instances. So we'll just OK that. And there we have the teeth, as you can see. And all we need to do now is put some smoothing on there. And let's just go turbo smooth. This will be an instance modifier because these are instanced objects. So we can just choose how much smoothing we want. Because these are so small, we don't really need that much smoothing. 2 levels of smoothing is probably just fine. If you look at this, you know, you're going to be seeing this from a distance. And you can see it looks just fine with 2 levels of smoothing. At the moment, all of these objects are instances and they're individual objects. So you can see I can select each one individually. And what I would do is to actually make the cog work better. If you actually rotate the cog at the moment, the teeth aren't actually going to go anywhere. So that isn't very good. So what we need to do is we just need to select all the teeth. So let's just go into this dialog here. Let's find the teeth. There we are. There'll be 48 of them. Select all of those. And let's just go here. Using the link tool, we can now link all of these to the cog. And now if I rotate the cog, all the teeth should rotate as well, as you can see. They're rotating just fine. And that's actually probably the most efficient way you can model the cog, because it means that all of the teeth are instances, and therefore at render time, most rendering engines will actually just have one copy of that piece of geometry, and they'll just translate it at render time into the position that they needed to be in for rendering. So it's a very efficient way of producing scenes by using instance geometry. So that's basically it for this section of the DVD. We've modeled various elements here, the running board of the car. We've modeled the mudguards, the seat, the hood, and we finished off here with the cog. And as you can see, sub-Ds are very flexible in what you can do with them. You can model very large, flowing organic objects like the hood of the car and the seat. And you can also model quite tight, sharp, engineered objects such as this drive cog that we have here. Now, in the next section of the DVD, we're going to come back to many of these elements, and I'm going to show you some modifiers and some techniques that you can use to actually make your modeling workflow a little bit more efficient and effective. And also, I'm going to show you some ways that you can actually optimize your scene so that display takes a little bit faster, which means that you can actually show more polygons and have basically the polygons only turn up in your scene at render time. So I'm just going to show you some optimization techniques in terms of getting your scene to be usable by animators and people in production, and to also ensure that at render time your geometry comes out at the highest quality possible. So let's move on now and go into the next section.